unordered rectangular array of numbers or functions. The numbers of functions are called the elements or the entries of the matrix. Let's consider a matrix. Matrices are denoted by capital letters. In this matrix, each number is an element. The horizontal lines of the elements are called rows. This matrix contains 3 rows. The vertical lines of elements are called columns. This matrix contains 3 columns. There are matrices of varied sizes. The size is termed as order while referring matrices. The order of a matrix corresponds to the number of rows and columns the matrix has. In the matrices shown, the first matrix is of order 3 by 3, which corresponds to 3 rows and 3 columns. The second matrix is of order 2 by 3, which corresponds to 2 rows and 3 columns. The third matrix is of order 3 by 2. On generalizing, any matrix can be considered as a rectangular array of elements with m number of rows and n number of columns. The alternative representation of the matrix is as shown. The subscript ij for the element A indicates the position of each element in the matrix. I represents the row and j represents the column where the element is located. For example, the element A23 represents the element in second row and third column of the matrix. The value of I varies from 1 to m. The value of j varies from 1 to n, where both I and j belong to the set of natural numbers. There are various types of matrices, depending upon the elements present in the matrix. First, we will start with the column matrix. A column matrix consists of only one column. An example of column matrix is shown here. In a column matrix, each row will only have one element. The matrix shown here is of order 3 by 1. The general representation of a column matrix having m rows is as shown. A matrix is said to be a column matrix if it has only one column. Similarly, a row matrix will have only one row of elements. A row matrix is shown here. In a row matrix, each column will have only one element. The order of the matrix shown here is 1 by 3. The general representation of a row matrix having n columns is shown here. A matrix is said to be a row matrix if it has only one row. A matrix having equal number of rows and columns is called a square matrix. A matrix of order 3 by 3 is shown here. This matrix has 3 rows and 3 columns. General representation of a square matrix of order n by n is shown here. A matrix in which the number of rows is equal to the number of columns is said to be a square matrix. We will move to the next type of matrix. Consider a matrix where all the elements, except the highlighted elements, are zeros. These elements are called the diagonal elements of the matrix. These kind of matrices are called diagonal matrices. The general representation of a diagonal matrix is as shown here. Let's see how this general form is implied to the example shown. A square matrix is said to be a diagonal matrix if all of its non-diagonal elements are 0. For a diagonal matrix, if all elements along the diagonal are equal to each other, then the matrix is called the scalar matrix. A scalar matrix can be represented as follows. Let's use the example matrix to understand the general form. This means that for I naught equal to j, the element is 0, and for I equal to j, the element is a non-zero number j. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. In a scalar matrix, if all the diagonal elements are equal to 1, then the matrix is said to be an identity matrix. Identity matrices of order 2 by 2 and 3 by 3 are shown here. Identity matrix is a special case of scalar matrix with diagonal elements equal to 1. General representation of identity matrix is shown here. The general representation is used to explore the example as shown. A square matrix in which the elements in the diagonal are all 1 and the rest are all 0 is called an identity matrix. When every element of a matrix is 0, the matrix is called a zero matrix or null matrix. A matrix is said to be zero matrix or null matrix if all its elements are 0.